Kinetics in this video. We're going to be using your TI-84 calculator to determine the rate order of a reaction through a graphical method. So integrated rate laws, concentration versus time in kinetics. How do we use those rate laws? Remember, we're going to make 3 plots, all of them in the form of a linear equation. M is the slope, B is the intercept. Your model 0 order kinetics is going to be this. You can compare y is concentration, x is time. So your graph should be concentration versus time. For the first order, this is the integrated rate law. So your plot should be natural log of the concentration versus time. For the second order, your plot should be the inverse of the concentration versus time. With this plot, how do we decide which one is better? We're going to be looking at the R-square value that comes from your linear regression. The one that is closest to 1, we're going to consider that as the truly linear graph. Okay? This is an example that we're going to work out. Time is going to go in the x-axis. The concentration is going to be in the y-axis. We're going to manipulate the data so that we get our graphs, and based again on the value of the R-square for each one of those from linear regression, we're going to decide which one is the best model, and we're going to consider that as the rate order for my reaction. In the TI-84 calculator, there are different settings that you have to make sure that you set up. You can always come back to this part of the video, pause it, and if you want some reminder. This one first. This is very important. We're going to look at the values of R-square. Actually, I already have my table here to note those values of R-square for each one of my linear regressions. By default, not every calculator is going to display R-squares. So to do that, make sure that you go first to mode, and then make sure that the stat diagnostics is on. Here it's off. So let's go all the way to here and select it on, enter. Now we are good to go. We're going to go into linear regression. That's on the stat mode. So we're going to go and start doing that. Stat, edit, number 1, you have your list. This is where you enter your data. In the first column, you're going to enter time. You can see that it's from 0 to 60. So 0. The first linear equation, or the first data that we want to graph, is concentration versus time. So let's go to stat, calculate. We're going to do linear regression, so that's going to be number 4. X is L1, Y is L2. And we're going to make sure here, this is very important. If you want to see the line from linear regression plot in your graph, you need to do this. Store regression equation, vars, select y vars, number 1 for functions, and we're going to select the first y1 since this is the only one that we have. And then from here we can calculate, and we're going to get the parameters for our linear regression for that one set of data. Now, one thing that you want to note, these values are stored in the variable y1, but these ones are not. So you want to make sure that you note this one somewhere. So let's see, the first one, it was 0.948. There you go. That's it for the first model. If that's all that you want, that's where you will stop. But remember, we have to compare the 3 models to see which one is the best one. So let's go back to stat, edit. Now we're going to go to list number 3. Don't enter your data like this, natural log of 0.0165. That's going to take a lot of time. Instead, go here. It's L3 equals. We want to calculate the natural log of all these values, which are stored in list number 2. List number 2 is here in your key 2. List number 3 is going to be in key number 3. List 4 in key 4, etc. So second function, L2, close parenthesis, enter. Now you calculate all of them at the same time. Now for this is going to be the inverse. Parentheses, again, list number 2, close parentheses, and to the -1. So now you have all the data that you need. It calculates the natural log of the concentration, then the inverse of the concentration. So we're going to do linear regression for each one of those. Stat, calculate, number 4 for linear regression. Now it's not list 2, we need list 3. So we're going to go to list number 3, and then store the regression equation, variables, go to yvars. Now this is the second one, so let's do functions and let's store that in y2. Then let's calculate. Now it gives you the parameters, and then come and check your value for the first order reaction for r squared, 0.9997. Looks pretty good, better than the 0 order. Let's do it again for the third one. So let's go to calculation, linear regression. Now this is not list 3, it's going to be list number 4, and let's store the variable in the results for the equation in y variables function, and let's do number 3 since this is the third that we are doing, and then go to calculate, enter. There you go. Now you note the value of the r square. This is 0.936. There you go. Now you can clearly see that the first order reaction is a better model in this particular case. Good. That's it. That's what we need. Now we know that out of these 3, the second that we did, the natural log versus time, that is natural log of the concentration versus time, is the really straight line because it has the best r squared closest to 1, so the reaction is first order. How do we plot this? If you come to this y, you're going to see that all your equations were stored in y1, 2, and 3. This is the second model, so that was y2. Let's go to equals, enter. So now you can see that it's deselected here, the black box, that is active. So let's deselect this by going into the equal sign, enter, and now it is deselected. Let's go to plot number 2. Let's activate that one. Let's go to stat plots, second function plots. Now second plot is active. Let's go into this one, and let's just change these values for y because it's not list number 2. List number 2 is concentration. Number 3 is the natural log of the concentration. With that, we can do graph, and now you can see this is your plot. It is going to be in the 4th quadrant as we were expecting from the values of the slope and the intercept. If you want to see it better, zoom, do 9 for zoom statistics, and there you go. Now you can clearly see a very nicely linear graph. You can also check here in trace. You can go and check the values that you enter in your table, either up or down arrows. Here you're going to go into the moving into the line, so you can now see values that are interpolated between points. Let's plot another function. Let's go to y values. Now let's say that we want to plot this graph. Let's select y1. Let's unselect y2. Let's go and activate plot 1 but deactivate plot 2. Let's go back to stat plots and let's enter here, and this is what we want, L1 and L2. Good. Now we graph. Now zoom. Let's do standard first to locate my plot. It's going to be here in the first quadrant. It's kind of hard to see. I'm going to come and do zoom and then 9 for zoom statistics. And now this is going to give me in the first quadrant my plot. And you can see that it's pretty much like what we had in here, but also the linear regression, the correlation is not that great as it was with your first order reaction. Okay, let's go back again. Let's just plot the one that was the most linear. So remember, this is my equation. You can see your slope and your intercept in this. Let's deactivate plot 1. Let's activate plot 2. So let's see, plot 2 is active, L1 and L3, that's what I wanted. Let's do the graph. It seems like there's nothing, but if you click on zoom, or press zoom and then zoom statistics, it's on 9. There you go, that's your plot. That was your equation. You can do a sketch. The slope is negative, so that's why this one is coming down. The intercept is going to be a negative number, so around minus 4.1. There you go, that's your sketch for your plot. And remember that the equation gives you y and x. That's not what you measure in the lab. You measure concentration and time. Specifically, you're plotting the natural log of the concentration versus time. Also, make sure to note what are the units of the slope. So your equation cannot be written down this way. The correct way to write down your equation is natural log of the concentration equals the value of your slope times the units of your slope times t, which is your x variable, minus the value of the intercept. Now with this one, we noted what the axes are. So the answer is first order reaction, and you can write down your rate equation as rate equals k times the concentration to the power of the order. The order was determined to be first order. And remember, the value of the rate constant is minus the value of the slope. So this is your rate equation. You can also come here to calculate. You can use this equation to calculate what is the natural log of the concentration at any time. So for example, again, 30.5. You can calculate the value, and your value is going to be 30.5, corresponds solving this equation to the natural log of the concentration. So be careful, because your y is not concentration directly, is the natural log of the concentration. So you will have to come back and say for x equals 30.5, you get the natural log of the concentration equals to minus 4.98. So e to the minus 4.98, that's going to be the value of your concentration. Okay, this is all that I have for you. Please let me know if you have any questions, but there's nothing else than just practice and practice. I'll see you soon.